Today we will discuss turning points and relation between eccentricity and energy. So, what are turning points and what is the relation between eccentricity and energy? So, with the concept of turning point, we will find the relation between eccentricity E and capital E, that is small eccentricity, capital E energy, and we will use to derive this relation the concept of turning points. So, what is turning points? We know that at turning point kinetic energy, that is half mu r dot square, is 0, because r dot is 0 at turning point. R dot means velocity is 0 at turning point. So, we have discussed this article in previous lecture. Now, our next task is to prove the formula between formula for eccentricity in terms of energy. So, we will use the concept of energy. So, we have energy is equal to half mu r dot square plus L square upon 2 mu r square plus u. So, we have already proved this equation. Let this equation number 1. Using the concept of turning point, that is the condition of turning point is this term becomes 0, because for turning points the equation will reduce to L square over 2 mu r square plus u, this one, because first term becomes 0. Now, we will change this term, this equation, into r term. So, this is already in r and we will reduce this u in terms of r. So, what is u? We know that if the force is central force, the energy is inversely proportional to r, that is minus k by r. So, you have already read that potential energy of two charge particle is minus k into q1 q2 by r, and the gravitational potential energy is minus gmm upon r. So, that constant gmm, this is written as k, and negative sign shows the attractive energy. So, we will write this u as minus k by r. So, it will become E is equal to L square upon 2 mu r square minus k by r, this one. Now, reduce this equation into quadratic equation. So, this will become take this term on left hand side and we will get it is L square over 2 mu r square, this one, and minus k by r, and this E become 0. So, what is this? This is nothing, this is quadratic equation. So, it is quadratic equation in terms of 1 by r, this one, because it is 1 by r square and it is 1 by r and it is constant. So, it is quadratic in terms of 1 by r. This is quadratic equation. Now, we know the solution of this quadratic equation, that is solution of this equation is that 1 by r is equal to, solution means 1 by r means variable is equal to minus b. We know that solution of the equation is x is equal to minus b plus minus under root b square minus 4ac upon 2a. So, I am using this formula in this equation, and x is taken as 1 by r. This is 1 by r square and 1 by r, that is x. Just it may be considered as x. So, 1 by r is equal to minus b. What is b? Minus k. This one b, and plus minus b square under root b square minus 4ac. This one b square means minus k square, that is k square, minus 4a. What is a? A is L square by 2 mu. This one. This is a, because 1 by r square is variable. So, minus 4a into c. C means minus e. So, it will become plus e. Minus into minus. Over 2a. 2 into a. What is a? A again L square over 2 mu. This 2 to cancel. So, this is the solution for quadratic equation. We all know this equation, this is the solution, and we will simplify this equation as we will divide this term with first and second. So, it will become mu k over L square, this one, and plus minus under root, this one is mu upon L square. It will become mu upon L square, and under root k square plus 4 e L square by 2 mu, or 2 may be cancelled out with 2. And finally, we will get 1 by r is equal to mu k over L square plus minus, and we will take this term inside the under root. So, it will become mu square and L 4, or take this k square as common. Both solution have the same answer, that is mu into k over L square. So, what I have done? I have taken the common k square from these two terms within the under root. So, k square is common and it will become k outside the under root. So, it will become mu k upon L square, this one, and under root of 1 plus, and k square is common. So, dividing this by k square, it will become 2 e L square over mu k square. Is it clear? So, this is solution. This solution is very complicated or very complex, but we will correlate this equation with the equation of conic. So, what equation of conic? So, we will correlate this equation with equation of conic. So, what is conic? 1 by r equal to 1 by L into 1 plus eccentricity into cos theta minus theta naught. But there is no any cos function or sin function. So, we will reduce this cos or sin, we will take its maximum minimum value. You know that the maximum value for cos theta is plus 1 and minimum value is minus 1. This is maximum and it is minimum value. So, these are the maximum and minimum value for cos function. So, it may be written as 1 by L into 1 plus minus E, because plus minus means plus for maximum value minus for minimum value, and it is a maximum minimum. So, it will become 1 by R like this. So, I am comparing basically this solution with the equation of conic at maximum and minimum values. So, we will reduce this equation as this. Therefore, let the equation number 2. So, equation number 2 may be written as 1 by R is equal to, take mu k upon L square common, L square is common, and it will become 1 plus minus under root of 1 plus 2e L square over mu k square. Is it clear? This one. Now compare this equation with standard equation of conic at maximum minimum values. So 1 by r is 1 by r, and 1 by l it is 1 by l. 1 plus minus, and this one is eccentricity. So this is eccentricity basically, and it is 1 by l. So on comparing this equation with the standard equation, we will get L is equal to 1 by L is this, and L is equal to L square upon mu k square. Mu k, sorry. This is L. And what is E? And E become this one, under root of 1 plus 2e L square over mu k square. And this is semi-latus rectum, and this is eccentricity. So we have got these results by comparing the solution of second order differential equation with the standard equation of conic. So this is the formula for eccentricity. So this formula correlate eccentricity with energy. So it is EE formula, that is the relation between eccentricity and energy. So this is E is equal to 1 plus 2e L square over mu k square under root. So it is also formula for eccentricity, but in terms of energy. Now we will find the solution or find the conditions for eccentricity. So you know that there are 4 conditions. First condition is when eccentricity is more than 1, and second is eccentricity equal to 1, third one is less than 1, and fourth one is 0. So you know that there are 4 values of eccentricity. So similarly, we will find these conditions in terms of energy. If E is more than 1, it means E is equal to 1 plus something. Something means this term. If this term is positive, then 1 plus positive means more than 1, this one. So therefore, E must be more than 0. More than 0 means positive. You know that more than 0 is positive. So when this E is positive, other terms are already positive. If E is positive, then 1 plus positive means more than 1, this one. And second, E is equal to 1, small e is equal to 1. How we get this E is equal to 1 condition? E is equal to 1 if this term becomes 0. It means if E is 0, then whole term becomes 0, and 1 plus 0 is 1, and under root of 1 is 1. This E is equal to 1. This implies capital E is equal to 0. And third one, E is less than 1. How we get this condition from this equation? E is less than 1 means 1 minus something. You know that when something is subtracted from 1, then the term is less than 1. So this term, if this term is negative, it means the energy should be negative, that is less than 0. 0 means less than 0 means negative. So negative means if it is negative, whole term become negative. So 1 minus negative means less than 1. So 1 root of less than 1 is less than 1. Therefore, this condition satisfied by condition of energy is less than 0. It means the 1 1 is reduced to 0 0. And at last, at what condition E becomes 0? Small e becomes 0. So small e becomes 0 if this term is minus 1, because 1 minus 1 is 0, and this term is 0. So this implies 2e L square upon mu k square is equal to 0, and hence E sorry 0, so no, it is minus 1, not 0, because we will get the whole answer 0. So this term is minus 1. So 1 minus 1. So this term is equal to minus 1, and E is equal to minus mu k square, this one, over 2 L square. So this is the fourth condition. it is also negative value of E, but it is the minimum value below which this eccentricity have no meaning. So, this is last negative value for this condition. So, there are 4 new conditions which are not new basically, these are obtained in terms of energy, but from eccentricity. So, these are again conditions when energy of the particle is more than 0, then the first condition used for hyperbola, then path followed is hyperbola. If energy is 0, then path followed is parabola. Path followed is parabola. And if eccentricity is less than 1 or energy is less than 0, that is negative energy, we will get equation of ellipse or the path followed by the particle which is moving under inverse square force follow elliptical path. And last one, when E is 0 or capital A is just constant value, negative constant value. So, this at this value the path followed by the particle is circle. So, these are again 4 conditions, but in terms of energy. So, same article in terms of energy we have solved. So, this is important formula for eccentricity in terms of energy. Now, we will discuss Kepler's laws of planetary motion. So, what are Kepler's laws? Kepler's laws of planetary motion. So, what are Kepler's laws? As you know that we have read that there are 3 laws of motion for simple motion, that is Newton's laws of motion. Similarly, there are 3 laws for planetary motion. So, these laws specially utilized and describe the motion of the planets, means the motion of Earth, Mars, Jupiter and other planets around the Sun. So, we will discuss these laws especially for Sun and Earth. So, there are 3 laws. First law, it is also called law of orbits, and second law is also called law of area or aerial velocity or aerial velocity. And third one, what is third Kepler law? It is law is T square proportional to E cube. It is totally mathematical. So, there are 3 laws of planetary motion described by Kepler. So, we will discuss these laws in detail in the next lecture. Thank you very much.